Now that we've had the opportunity to learn about piecewise functions, we're going to look at a piecewise function that most people probably know already, but do not realize that it's a piecewise function, and that's the absolute value function. And so the absolute value function actually looks like this as a piecewise function. So if I said f of x equal to x or negative x, but over a range of x values. So for x, we want all of the x values greater than 0. We could say equal to 0. And for negative x, we want all the x values less than 0. And so that would create this situation here where we have part of the diagonal going up that way, and then we have the other diagonal coming this way. And so that would create those two lines meeting at a point of 0, 0, which we're going to call our vertex. And so that point where they meet is going to be the lowest point on the graph, what we call a minimum or a vertex in this case. And so that's really, absolute value is really a piecewise graph. Now, in general, we've learned that the absolute value looks like that. And so that basically means the same thing as the piecewise function up above. And so we know that absolute value means that we can't have a negative number. Whenever we plug a value in for x, we're going to get a positive number out of that absolute value. And so this is the graph that it creates. So you can look at the absolute value graph and you can think of it as a parent function. If you recall our previous parent functions, they all tended to move around the graph, the coordinate plane, similar. So they can shift left to right, or they can shift up and down, which is called translations. They can also reflect over the axis or a line and have line symmetry. And so there's a number of different things that acts the same as our prior parent functions. So what we're going to do for this verse video is just go through an exercise of recognizing all of the different translations that we've done prior to this and see how they work with an absolute value function. So you can always know that an absolute value function is going to make a v and come to a point called the vertex, and so that's going to be pretty consistent. For the parent function, y equals x, you could also think of it as f of x equals the absolute value of x, is always going to be a vertex at 0, 0, and then it's going to have more or less a positive 1 slope on the positive part and a negative 1 slope on the negative part. And so what we want to do here for sample problem number 1, what I would like you to do is to go ahead and graph y equals to the absolute value of x, then graph y equals negative absolute value of x, and then tell me what's changed from the original parent function to the part B function. So go ahead and take your time and do that right now and come back and check out the answer.